I slept on myself for way too long. I underestimated the gifts that God gave me for way too long.
Hello, welcome entry students. We are still dealing with generators and motor calculations, and this is part 2 where I'll be dealing with motor calculations. If you didn't see part 1, please go and check it out so that we can move further, because there I have all the formulas and everything that you need so for you to be able to derive and calculate. Okay guys, so let's continue with the lesson. The question says a 6-pole DC motor has a wave-wound armature with 88 conductors. So let's write down the given. That's what I like to do when I get the question, is to write down the given so that I don't confuse myself further. A 6-pole DC motor has a wave-wound armature with 88 conductors. 88 conductors, that's a Z is equal to 88. 88 conductors. When rotating at 1000, that is n, which is speed 1200. The generator EMF is measured and found to be, we have E again, which is 305. Calculate the useful flux and express the answer in milliwebs. So we are looking for a flux. Given this information, we have, a 6-pole DC. It's a wave wound. Remember that we are looking for this. Remember that a wave wound is equals to 2C. Just gonna be C is equals to 2. Wave wound. C is equals to 2. While if it was a lap, it was gonna be 2P, 2 pole. And what is P? If it's a 6 wound pole is a 6 minus by 2. Anything that is pole, we divide it by 2, get the answer to be 3. Now let's work it out. Obviously we're going to use this formula because of what we are given. E is equals to 2 Webers and P Z over 60C. So let's write down what we were given. They said E is 305 is equals to 2. What is Webers? We are looking for it. We don't know, we are looking for it. And 1200. P pole is 3 and Z is 88 over 60 times 2. We are looking for this, so it's going to be 305. Let's calculate everything on top. 2 times 1200 times 3 times 88 divided by 60 times 2. Get the answer to be 5280 Webers. So that means Webers is equal to 305 divided by 5280. So the answer of Webers will be what? Get the answer to be 0,0578. That's what I get. What did you guys get? What did you guys get? Get my answer to be that? $0.57 everything 2 times 1200 times 3 times 88 divided by 60 times 2, 305. This is what I get, guys. This is the answer that I've got. Milliwebs. Webers. Okay, guys, let's move further. Question number 2. A lap wound armature has 56 slots and a 10 conductor per slot. Calculate speed at which the armature of this 4-pole machine must rotate in order to induce an EMF of 400 volts in armature. Take the flux per pole to be 25.5 milliwebers. Okay, guys, so let's write down what we are dealing with. So we can see first thing we are dealing with a lap wound. A lap wound, that means C is equals to 2 times pole. We will see how much pole it is. Has a 50 slots and a 10 conductor per slot. That is a Z. That means we're going to multiply 56 times 10. How many all in total? 56 times 10, 560. We got 560. Right, calculate the speed. So we are looking for N. We don't know what is N. Speed at which the armature of this 4-pole, you see it's a 4-pole. That means P is going to be 4 divided by 2, which is 2, and 2 times, it's going to be 4. This is going to be 4. 2 times P, it's going to be 4. Must rotate in order to induce an EMF. We have E2 of 400 in the armature. Take the flux to be, we have the flux 25.5 milliwebers times 10 negative 3. So let's work out everything we have to solve for N, right? So we know that we're going to use this again. E is equals to 2 times milliwebers times N P Z over 60 C. So let's, E is 400, 2 webers is 25.5 times 10 negative 3 webers, and we have N, P is 560, P is 2, and Z is 560 over 60, C is 4. So let's work out everything that we have. 400 will still continue to be 400. Let's work out everything at the top. 2 times 25.5 times 10 negative 3 times 2 times 560 divided by 60 times 4. Get the answer to be 0.238 N. So N is going to be 400 over 0.238, right? So let's work it out. 400 divided by the answer. I get my answer to be, for my N to be 1,680.67. This is the speed, guys. 1,680.67. As long as you know how to use your formulas, you can be able to calculate anything, guys. So let's move on. Okay, guys, a 6-pole DC machine has a wave-wound armature with 8 conductors per slot. The motor develops a torque of 150 newtons per meters when a 28 ampere flow through its armature. Useful Webers is 0.05 Webers. Calculate the total number of conductors and number of armature slots. Now we are dealing with a torque. Remember, guys, the formula of a torque. We are dealing with a torque. Let's write down what we are given first. Okay, we are given a 6-pole DC machine has a wave wound. It's a wave wound, so that C is just going to be equal to 2. But we have a pole, 6 divided by 2, which is equal to 3, which N is going to be equal to 8 conductors per slot. And there, I need Z. A torque T of 450. We also have I of 28. Flow through armature useful Webers. It's given flux per pole 0.05. Calculate the total numbers of conductors. So they're still looking for conductors even if we have this 8. Okay, guys, so the formula of a torque is T is equal to 0.318 I A. Just want it to be like very visible. 0.318 IA Webers PZ over C. That is the formula, guys. So since we have the formula, we're gonna have to substitute T. Are we given T? Yes, we are given 450, which is equal to 0.318 I. Do we have I? Yes, it's 28. Do we have Webers? Yes, they gave us a Webers of 0.05. Do we have a P? Yes, it is 3 times 3. Do we have a Z? Yes, we are given 8. We are given 8, but we are looking for the number of conductors. We are still looking for it, still. Because the question says calculate the number of conductors, and Z stands for conductors, and yeah, that means we still have to work it further. This is not the real answer, it's not done, right? And we multiply only by 2. So multiply everything by 2 times Z on top. So 0.318, right, times 28 times 0.05 times 3 times 2 divided by 2. I get my answer to be 1.3356Z over 450. So Z is equals to be 450 divided by 1.3356. So what is Z? What is Z? 450 divided by what we get, right? 450 divided by 0.318 times 28, right? I get my answer to be think I did a mistake here. Let me start here on top again. 0.318, right, times 28 times 0.05 times 3 times 3. Oh, I forgot to divide it by 2. Divided by 2. I forgot to divide by 2. It's 0.6678. And then that means here we're going to say 450 divided by 0.6, 6678. So yeah, now we can do it. 450 divided by the answer. I get my answer to be 673,85. 673,85. Still, they also want us to calculate the number of armature slots, and now we are calculating for Z, the full Z, guys. Okay, so 600. Okay, we just got that, and now they just wanted the number of armature slots. So number of armature slots is going to be Z over that 8. Remember that 8. And we got Z to be 673,85 divided by 8. And I get my answer to be 84, right? 84,23. And that is the whole thing, guys. So let's move on to another question. Okay, guys, the question is read as follows. A 6-pole shunt motor has a wave-wound armature with 64 slots and a resistance of 0.15 ohms. The input power to the motor is 15 kilowatts from 300 volts supply for a speed of 1,200 rev per minute and a useful flux per pole of 0.016. Calculate the armature current if the shunt field resistance is 150 ohm, the EMF, and the number of conductors. So let's write down the given first. You write down the given first. A 6-pole shunt motor has a wave-wound. It's a wave-wound. So C is going to be equal to 2. Pole is going to be equal to 6 divided by 2, which is equal to 3, which a slot, 64 slots. So if it's a 64 slots, that means it's not finished, because it was supposed to say a number of conductors. That's why we have to calculate it. So Z is not finished. It's 64, but still not finished. And a resistance of 0.1. And R, it's 0.15 RA. 0.15 because it is armature, a wound armature with a resistance of. The input power to the motor is 15. P power is going to be 15,000 from 300 volt supply. So we have voltage of 300. For a speed, we have N of 1,200 R per minute and a useful flux. And yes, we have a flux of 0.016. Calculate the armature current. Okay, so we have to calculate for IA, the armature current. So what do we have here? Here we are given C, we are given P, we are given Z, we are given RA, power, V, N, and Webers. But we don't have any current, right? So how can we calculate for A current, we have P, so let's use P. We know that P is equals to voltage times IL, right? So if P is 1500, 15,000, I mean, right, 1 comma 15,000 to 1 2 3 voltage, cost of voltage 300 IL. So IL is going to be 15,000 divided by 300. So 15,000 divided by 300, how much is it? 15,300. I get my answer to be what? 50. So let me write it here. That means IL is going to be 50. So we are done using power, right? We are done with power. We got IL, but IL, remember, is not the current. So remember, we also have this formula, IA, right? Right, yes, we also have this formula where IL is going to be equal to I shunt plus IA, right? IL is supposed to be I shunt. We have IL, yes, we do have IL, is 50. We just solve for it. So I shunt. So how do we solve I shunt in a parallel motor? R I shunt is equals to V over this. I shunt is equals to V over R shunt plus IA, right? So do we have a voltage? Yes, voltage is 300. Do we have R shunt? R shunt, R shunt. We have C, we have P, we have Z, we have RA, we have P, we have V. Okay, but let's go again. Calculate the armature current if the shunt field resistance is 150. So we are given it to be 150 plus IA. It's going to be 50. So 300 divided by 150. 2 plus IA is going to be 50. Taking it here. So IA is going to be equal to 50 minus 2, which is going to be equal to what? 50 minus 2, right, is 50 minus 2. It's going to be equal to 48. So IA is going to be 48A. So let me write it here. IA, we found it to be 48. So we are done with the first question. We are done with the first question. And then they wanted us to calculate the armature current if the shunt field resistance is 150, the EMF. They wanted us to calculate the EMF. So to calculate the EMF, we have two formulas. We have the V formula, right? And we have the two, NPZ, whatever. We cannot use this formula, two, P and P. We cannot use this formula Z. Why? Because we don't have number of conductors. If we had a number of conductors, we could have used this, but now we do not have, right? So we're going to calculate for E using this formula. It's a shunt V minus IA RA. So do we have E? No, we are looking for E. Do we have V? Yes, they given us is 300. Do we have IA? Yes, we do. It's 48. We just solve for it, right? It's 48. We just solve for it. And RA, they gave us to be 0.15 times 0.15. So 300 minus, 48 times 0.15. And I get my E to be 292.8 V. So we got E. Let me write it down is 292,8, right? So we are done calculating the E and F. And now lastly, they want us to calculate the number of conductors. Since now we have E, then we can use that formula now, because now we have E. 2 flux, speed, pole, conductors, number of conductors. So we are about to calculate for this, and 60 C, right? We have E is 292,8, which here we have 2. Do we have a number? Okay, flux number, yes we do. It's 0,016, right? Do we have N speed? Yes, we have 1,200. Do we have pole? Yes, pole is 3. Do we have Z? No, we are calculating for Z, right? Over 60. Is it a lap or is it a wave? It's a wave, so we're just gonna multiply it by 2. The wave, just gonna multiply it by 2, right? So let's solve for this. Just put it off. 2 times 0,016 times 1,200 times 3, right? Yeah, over 60 times 2. Get the answer to be 0,96 Z over 292,8. So Z is equal to 292,8 divided by 0,96. So what is Z, guys? What is Z? Z is going to be equal to 292,8 divided by, I get Z to be 305. It's going to be 305. What did you guys get? I get my Z to be 305. Hope you got the same answer. So I'm going to write it here on given 305. Right, number of conductors is not done. Remember, I said the wound amateur with 64 slots. That means the Z was not done because it has to be number of conductors, just like the question we did recently before we did this one. Just gonna do the same thing. So number of conductors is going to be equal to Z over 64. So Z is 305 over 64. So 305 divided by 64, and I get the answer to be 4,7, right? 4,77. It's 4,77 number of slots. Thank you guys for tuning in on Size Table. Thank you for supporting me. Please subscribe, please like, please comment, and tell me where to improve. Guys, let's continue to study together and let's improve, guys. Let's grow together. Thank you. Please share it with other students who don't know about the channel if you find it useful. And thank you guys. See you on the next lesson.